Hi, this is Saranya Chejalla. Welcome to ECP Tech. Now today in this class we will talk about what are the different type of switching techniques we have. Right? In the previous session we already discussed what is meant by switching and what are the different modes we have in a switching. So it is mainly responsible for data link layer, right? See, in this video we are going to learn about an different type of switching techniques. Let us get into the topic. So what are the different type of switching techniques will be there? We have a three types of switching. The switching techniques can be classified into three types: circuit switching, message switching, packet switching. Okay, circuit switching, message switching, packet switching. In circuit switching also it follows and two ways, and packet switching also it follows and two ways. So let us discuss what is meant by circuit switching, what is meant by packet switching, and what is meant by message switching, right? So first of all, the first one is circuit switching. The circuit switching is a switching technique that established a dedicated path between sender and the receiver. See, the circuit switching is one type of technique to provide or to establish a one dedicated path or channel, to establish a one physical channel, or we can call it as dedicated path between sender and the receiver. So by using this dedicated path we can transmit data from source to destination. This circuit switching is mainly used in telephone communication. The circuit switching is mainly used in telephone communication. So we can take the telephone communication as an example of circuit switching. Here in this circuit switching, whenever we establish a path from source to destination to communicate, the path will not be terminated until the communication end. The path will not be terminated and until the communication end. After the communication is terminated, the path will also be terminated. After the communication end or terminated, the path will be terminated. See, in case of circuit switching technique, user wants to send the data. It may be a voice or video or request signal, um, is sent to the receiver, and then the receiver sends back an acknowledgement to ensure the availability of the dedicated path. Okay, here see, whenever the in this particular circuit switching, whenever we wants to send the data, right, whenever we wants to, the sender wants to send the data, so it gives an one request signal to the receiver. It gives an one request signal. You can call it as 1 or 0, nothing, anything, one request signal to the receiver. If the receiver accepts that request signal and he give an acknowledgement, he sends an acknowledgement back to the sender, means there is an availability. uh, so I am accepting these signals. Let us ensure the availability of dedicated path. Dedicated path means establish a particular or a physical channel from source to destination, dedicated path. After receiving the acknowledgement, dedicated path transfer the data. See, I am telling once again, in circuit switching technique, whenever the sender wants to send the data, so first of all it gives an request signal to the receiver. If the receiver ready to take the data, he is available in the network, the receiver sends back one acknowledgement to the sender. Just establish a dedicated path between you and me, means sender and the receiver. Okay, so whenever the sender sees that acknowledgement, he establish a dedicated path from source to destination and transfers the data. The circuit switching is mainly used to transfer the voice signals. So I already said that the circuit switching is mainly responsible for or mainly work in the telephone network. We can take an example. Telephone communication is an example of a circuit switching. Okay, so this is a diagram. To establish and circuit switching, we have to create a three phases here. The first one, circuit establishment. See, circuit switching means here in between we have a different type of circuits. While sending while we are establishing a dedicated path, we have to establish by using that circuits only. So the data will be sent through that circuits to the destination. First of all, if you want to communicate data from source to destination, first of all you need to establish a circuit. Next, data transfer. Once the establishment of circuit is done from source to destination, you can transfer the data. Okay. Next, after the completion of this communication, disconnects the circuits. After the completion of this communication, disconnects the circuit. Let us see the diagram, how the circuits will be established, how the dedicated path will be established through these circuits. How can we can transfer data by using by using the circuits from source to destination, right? Let us see an example here. Sorry, diagram. See, this is the diagram. Here, the S1, S2, S3, S4, S5 and S6. So, this is the A will act as a sender and B will act as a receiver, right? The A will act as a sender and B will act as a receiver. So, I want to send the data from source to destination. So, before sending the data, the sender will give and one request signal. Request signal, we can call it as RS. Request signal to the receiver. While the receiver is ready to accept that particular data from the sender, he gives an acknowledgement to establish a path. Here, I established one dedicated path, right? So, from S1, S2, S4, S6 to destination. Here I use and three circuits. I establish one dedicated path, four circuits, S1, S2, S4, S6. So these four circuits first I established these circuits. So here I established one dedicated path by using these circuits and I transfers the data here. See, observe this diagram carefully. This is a message, means data. So that will be go in this path through these circuits. So this is an circuit switching. So mainly the circuit switching used for a telephone communication. It is it is not suitable for device to device communication. Nothing but an computer to computer communication. It is not suitable. So mainly the circuit switching uses in telephone communications or telephone network. Let us see what are the advantages and disadvantages of a circuit switching. See, before going to the circuit switching advantages and disadvantages, and it also use in two process or two ways, nothing but a space division and time division. Space division means this is an example of before we discussed one diagram, that is example of a space division. We establish one dedicated path through the circuits. We can pass the message or we can transfer the data by using that circuits, right? Time division means the particular time will be divided into number of slots. Within time period we can establish a dedicated path, we can send the data. See, mostly in circuit switching we use as space division. Okay, this process we use for an telephone communication, right? Next, let us see then advantages of circuit switching and disadvantages of circuit switching. See, advantages of circuit switching. In the case of circuit switching technique, the communication channel is dedicated, nothing but an fixed. Dedicated means fixed. So, by using that fixed channel, we can transfer our data or we can pass our message from source to destination. So, it has a fixed bandwidth. So, whenever we want to increase or extend a particular bandwidth while transmission, okay, Dynamically, it is not possible. One fixed bandwidth will be allotted to communicate from source to destination. In that fixed bandwidth only, we can communicate data, right? So, disadvantage of circuit switching. Once the dedicated path is established, once the dedicated path is established, the only delay occurs in the speed of transmission. Here, the delay process will be there while transmitting data from source to destination. While transmitting data from source to destination, right? It takes a long time to establish a connect because we are establishing a one fixed channel from source to destination. See, this establishment is a little bit complex. It takes a long time. It is and in another disadvantage is it is more expensive than other switching techniques. It is more expensive than other switching techniques. So this is about an circuit switching. Next, packet switching. So in the previous classes, I already told that what is meant by ARPANET means it is the first packet switching technology used in the world. I discussed in the previous classes. Just a look at that. So packet switching. Packet switching is a one type of switching technique and it is a very efficient switching technique. Efficient switching technique. See, in this packet switching, our data or our packet will be divided into the small parts or small pieces. Okay, so the entire message will be divided into number of packets, and each packet will be allotted by an unique number or a sequence number to identify the order at the receiving end. See, in this packet switching, we will send different type of packets like different type of packets by using a different type of routes. Here, each and every packet has maintained one sequence number because do not miss the order. Do not miss the order because the entire message will be divided into number of packets, right? So if you want that message in an one type of procedure, one readable format, we have to provide a sequence number or unique number to each and every packet while divide the message while divide the message. See, each and every packet contains some information at the header part. So while the data, whatever the data want to communicate from source to destination, this data will be divided into number of packets and each packet maintains one header. Each packet maintains one header. So this header contains source address, destination address, sequence number. Source address, destination address, and sequence number. Source address, where it comes from. Destination address, where it go to. Sequence number. To do not miss an order of an packet. Do not miss an order of the packets. See, the packets will travel across the network taking as shortest path as possible. Here, one of the main advantage of a packet switching is shortest path. Okay, so while traveling or sending the packets across the network from source to destination, it is easier to choose a shortest path to send that packet. Okay, whenever all the packets are assembled at the receiving at in correct order, so in different parts it will choose in packet switching while sending these packets by using a router. Okay, it receives a different it takes a different shortest path. By using the shortest path, we can send our packets at the receiver and the pattern will be missed. So here all the packets will be reassembled in a particular order because by using that unique number we can reassemble all the packets at the senders at the receiver side. So if any packet or if any packet are missing or corrupted, then the message will be sent to the resend the message. Here the entire message or data unit divided into number of packets, right? If any packet is missing, so the receiver will send a message to resend the message again, right? So if the correct order of the packets is reached, then the receiver gives an acknowledgement message. Whether the packets are not reached in an correct order, the receiver will not give an acknowledgement, it gives an one message to the sender to resend the message again. See, this packet switching uses two different type of approaches: datagram packet switching and virtual circuit packet switching. See, datagram packet switching, mostly we are using an datagram packet switching nowadays. Let us see what is meant by datagram packet switching. See, in this type of packet switching, each packet will be called as a datagram, will be considered as datagram. Datagram is independent entity. So the independent entity will not dependent on the other packets. Each packet contains a source address, destination address, and the sequence number. I already discussed in the previous. And in this datagram packet, this is an connectionless switching. This is an connectionless switching. Okay. Nodes. Intermediate nodes means routers. Intermediate nodes means routers. Here the packets are passing to an intermediate nodes in between, from one from source to destination. While traveling to the network, in between we have a communication devices or an independent intermediate nodes to send that particular messages from source to destination, right? See here, intermediate nodes take the routing decisions to forward the packets. Here, intermediate route means we are taking in this datagram packet switching, routers will act as an intermediate nodes. So the routers find out the best route or shortest path to send that packet from source to destination. Okay, so this process will be done by an datagram packet switching. And virtual circuit switching. Virtual circuit switching means it is a connection oriented switching. In virtual circuit switching, pre-planned route is established before the messages. So only one route is established. Connection oriented means only one route. Connection less means we have a different type of possible ways or different type of routes to send data from source to destination, right? So this is an connection oriented switching. And pre-planned route is established. Call request and call access packets are used to establish connection between sender and receiver. In this case, the path is fixed for the duration of logical connection. So let us see the difference diagrams of an datagram switching and virtual circuit switching. So we can easily identify what is the difference. How can we send the packets from source to destination by using these two types of approaches, right? Okay. So these are the diagrams of a datagram switching and virtual circuit switch. So this is an datagram switch and this is an virtual circuit switch, right? Okay, so these are the intermediate nodes. These are the intermediate nodes. So we are discussing firstly datagram switching. So this S1, S2, S4, these are the intermediate nodes, nothing but an routers. Nothing but an routers. And A is an sender and B is an receiver. A is a sender, B is a receiver. Here, see, the this is an entire message. This is an entire message that will be divided into four parts or four packets, smaller parts. So these are the four packets. So each packet will be assigned one sequence number or one unique number. 1, 2, 3, 4. So packet number 1, packet number 2, packet number 3, packet number 4. So the entire message will be divided into 4 packets. See, these are the intermediate nodes or routers. So the first from source or sender, that will be going to the first router or first intermediate node. So this intermediate node find out the shortest path to send this particular datagrams to the receiver. See, the 4 and 1 packets will be sent to the S2 and 3 and 2 packets will send to the S3 router. Okay, so the from S2 router, the first packet will send to the S4 next intermediate node. So find out the shortest path here. So the fourth packet will send to the S3. From S3, the 2 packet will send to the S2, and this is an shortest path from S3 to S4. Okay. So 4 and 3 packets are to S5. This is an S5. Okay. So by using these are the different routes. Here intermediate nodes decides the different routes or shortest path to deliver that particular packet from source to destination, right? So here whenever I send the all the packets to one intermediate node, that intermediate node or that router decides these packets will be sent in which intermediate nodes the shortest path or traffic less of the network. Okay, so these are the different types of paths they decide to send these packets from source to destination. See here, uh, here the packets received in the order 1, 3, 4, 2. 1, 3, 4, 2. First he received one, next 3, 4 packets, and after that 2 packet. So at the receiver side, this is an order missing. So it will be reassembled at the receiver side is 1, 2, 3, 4. So this particular responsibility will also taken by an packet switching. Next come to the virtual circuit switching. Virtual circuit switching. See, virtual circuit switching means we already discussed that one special path or one dedicated path. It is a connection oriented. One path is established here. So before sending that, okay, these are the sender and this is the receiver. First of all, to send a particular data frame, give an call request to the sender, sorry, to the receiver. If the particular receiver accepts that call, he is ready to receive the frame. He give an acknowledgement. After see particular the type of acknowledgement or message, the sender transfer the data to the receiver. Okay, the sender transfer data to the receiver, and acknowledgement at the receiver side, acknowledgement will be given to the sender, means the particular message will uh, successfully I received. So after see the acknowledgement from the receiver, clear the dedicated path. Who establish a dedicated path from source to destination or sender to receiver. So if you give a clear indication after the process is completed, entire process is completed, the path will be terminated. So these are the two approaches of an packet switching that we are using, datagram approach and virtual circuit approach. And mainly we are using an datagram approach because the datagram approach is an connectionless, and it will take an dynamic routes. The router will take a decision how the packets will be sent to the immediate intermediate node within a shortest path, right? So these are the datagram approach and virtual circuit approach. Let us see the advantages and disadvantages of packet switching. So these are the advantages of packet switching and disadvantages of packet switching. So cost effective, reliable, efficient. Cost effective means here there is no storing of packets. In this packet switching technique, switching devices do not require a max secondary storage, means any database to store the packets. So it simply delivers the packets from source to destination by using a different intermediate nodes, nothing but an routers. And the routers will identify and best route or the shortest path to send that particular packet from source to the destination, right? Reliable means it is very reliable communication. The data will be delivered in a reliable manner, means there is no chance for an there is no more chance to occur an error. Okay, to occur an error in our data frames, right? So efficient, it is very I already said it is very efficient technique. It does not require any establishment path to transmit. Many users use this particular packet switching or some communication channels simultaneously, right? These are the advantages of packet switching. Disadvantages of packet switching: the protocols used in packet switching technique. So this is the procedure of packet switching, right? We are using different type of protocols to design this type of procedure to deliver our data from source to destination. So what are the protocols used in this packet switching techniques is very complex and requires high implementation cost. Okay, if the network is overloaded or corrupted, then the packets will also lost. There is a chance of lost packets in between transmission. Okay, these are the disadvantage of a packet switching, right? Next, message switching, and this is the another type of message switching. In message switching technique, there is no establishment of dedicated path between sender and the receiver. So the best example of message switching is SMS. The best example of message switching is SMS. So in keypad phones we have a message sending, right? So that is the main thing. Here we know about and destination address. We have append whenever we want to send, we want to communicate, we want to send one message to the receiver, we have to append a receiver address or destination address to the message. And message switching provides a dynamic routing, and message is routed through the intermediate nodes based on the information available in the message. See, this type message switches are programmed to provide a more efficient routes. Here it is similar to the circuit switching, but there is only one dedicated path will be established by using these circuits. But here message switching, we establish a dynamic paths by using these circuits, and it is this type of network we can call it as a store and forward network. Okay, so each and every message as act as an independent. Here let us see the diagram of an message switching. We get a clear idea about an message switching. So this is the diagram of message switching. See here, the messages uses different circuits. Okay, so this is a store and forward network concept. By using these circuits only, the messages are transferred from source to destination. But here the only difference between circuit switching and message switching is, in circuit switching we have to establish one dedicated path to communicate, right? But in this message switching there is that mandatory thing. Here we can establish a dynamic route, and we can send messages by using a different type of routes. Here the first message will be sent by using an four circuits, S1, S2, S4, S6. By using these circuits we send a first message. After this we are sending second message, it will take an another part, right? See here, it will take an another part. So S1, S2, S4, S6. So different path it will choose a dynamic path, it will choose. And the best example of an message switching is an SMS. Okay, so this is an about a message switching. So let us see what are the advantages and disadvantages of message switching. So advantages of message switching: data channels are shared among the communicating devices to improve the efficiency of using available bandwidth. See here, data channels are shared means each the particular data channels will be shared different type of communication devices, means to give and to improve the efficiency of an available bandwidth. So traffic congestion means traffic will be reduced because the message is temporarily stored in the nodes. Message priority can use it to manage the network, because which message priority means which message will be communicate first in the network, that will be done by using a message switching. So these are the advantages of message switching. And we also have a disadvantages of message switching. The message switches must be equipped with sufficient storage to enable them to store the messages until the message is forward. Here, first of all, in message switching, the message is not directly sent to the particular receiver, so it will store first, then the receiver address will be appended messages. It will store first, and then, well, when available, it take a dynamic link dynamic route from source to destination. It will enable that or establish that from that dynamic path it will sense that particular message. Firstly, it will store that message. So the long delay can occur due to the storing and forwarding facility. Already said in the switching concept, store and forward switch, it is a time delay process to store that message, to append the destination address to the message, and you have to establish a dynamic path from source to destination, and then it will forward that message to the receiver, right? So these are the different disadvantage of switching techniques. See, these are the different types of switching techniques we discussed, that we classified into three types: circuit switching, packet switching, and message switching. I hope you understand, right? Kindly like, share, subscribe Easy BTech for more videos. Thank you.